Hello Math 7 students, this is Open Up Resources, Unit 3, Lesson 4, Applying Circumference. This is Part 2 covering this lesson. To get started, we have this quick poll. The circumference of a circle is 15.708 units. What is the radius round to the nearest tenth of a unit? So I remember from our previous lessons that the circumference is found, or excuse me, the relationship between the circumference and the radius is multiplied by 2, and then we multiply by pi. When I have the radius and double it, that's the diameter. Diameter multiplied by pi is how I find the circumference. So, since I know the circumference is 15.708, I can just solve this equation. 15.708 is equal to the radius times 2 times pi. Since ultimately I'm trying to get the radius all by itself, I'm going to undo what's happening to that radius. The radius is being multiplied by 2 and multiplied by pi, so I'm going to divide by 2 and pi at the same time. Whatever I do to one side, I do it to the other side. So when I have 15.708 divided by 2 pi, I end up with the radius is equal to 2.5000. Rounding to the nearest tenth of a unit is going to make that 2.5. So students, one actually entered r equals 2.5. That's fine because you solved the equation saying the radius is equal to 2.5. Everyone else entered the 2.5. Only one incorrect answer, so hopefully that student has found their mistake. Let's continue on in this lesson. Okay, so again, this is part 2 of this lesson, so we're going to skip ahead to just where we left off. Right here on 4.4, measuring a picture frame. Kiran bent some wire around a rectangle to make a picture frame. The rectangle is 8 inches by 10 inches. So again, we have this rectangle. We know the dimensions of the rectangle. They bent the wire, Kiran bent the wire in this shape around it to make that picture frame. We want to find the perimeter of the wire part of that picture frame. So all of this curly outside edge, we want to find out how much wire he used. Now, we can get started on this together, but I want you guys to see what you can figure out on your own first. Give it a try. Even if you don't finish, at least start putting your thoughts together. How are we going to go about this problem? I will start with this. The dimensions of that rectangle are up here. Let's at least write that down so that we're all on the same page. This side right here, which one is that one going to be? Yeah, it's a little bit shorter, so that one's going to be the 8-inch side, making this the 10-inch side. Since this is the 10-inch side, obviously this is also going to be 10 inches, and this is going to be 8 inches. I'm not going to say anything else. I want you to get started, and then we'll come back together to go over this. Pause the recording and give this a try. Ready, set, go. Okay, students in class have had a chance to work on this. And so even though we're probably maybe not all the way done with this, I want us to at least get started. How did you approach this problem? What did you see that helped you out? Zuri? Okay, the diameter is 2. How can we figure out the diameter is 2? It's correct, the diameter is 2. How do we figure that out using what we see in this picture? Gideon? Okay, the 8 on the top. Mm-hmm. Okay, cut these circles here into fourths. Okay. Like that? Okay. Control Z. Don't do that. Okay. Okay. Okay, pause there for just 1 second. We can see that here's half of a circle. So that line that I just drew, what is that line going to be called? Davin? Yeah, that's a diameter. So I have half a circle, there's the diameter. Half a circle, there's the diameter. Half a circle, there's the diameter, right? And I don't have a full diameter, but I can take this piece and combine it over here. And then I would have my fourth diameter, right? So half plus 1, 2, 3 plus another half is going to make a total of 4 diameters, 4 half circles. Yes. So right up here, we have that 8 inches that we can see is split into 1, 2, 3, 3.5, 4 circles. So 8 divided by 4 is how we get that each one of these diameters is 2. If that diameter is 2, just for funsies, what is that little radius going to be? Cambria. Yeah, that's 1. Half of 2 is 1. Great. Does that hold true for all of these ones too? Yeah, it is the same thing. So we have a diameter, a diameter, a diameter, a diameter. That's 1, 2, 3, 4 so far. But then I also can see I have a radius combined with another radius down here. A radius and a radius are going to create a 5th diameter. So now I have that 10 inches that's split into 5 different circles, making each one of those diameters for those circles 2 inches as well. So another 2-inch diameter, 2 inch, 2 inch, 2 inch, making each of these radii, that would be the plural of radius, is 1 inch. Okay, I like that. That is really, really good powers of observation to try and figure out what the diameter is of each one of those. What do I do now that I know that? What do I do now? Davin. Yeah, how many complete circles are there? Good. 14 half circles. Great. I like that strategy. I also, because I have the power of technology, I can pick things up and move them around, right? So I was able to pick up these half circles that were over here and just move them over here so I can count. 1, 2, 3, 4, 5, 6. Well, not really half circles because those are 3/4, right? But I have 1, 2, 3, 4 full circles. I picked this one up from down here, moved it up. 1, 2, 3 full circles now. I got a different count than you did though, didn't I? Because I had 1, 2, 3, 4 full circles, 5, 6, 7 full circles. No, you said that right. 14 divided by 2. Yes, so we have 7 full circles now. We have 7 full circles. Yes, Carter. Not forgetting, we're just counting the half circles right now. We didn't forget it. We're just counting just those half circles. The next step would be that's not all of those circles, right? So we also need to take into consideration, let me color code what we have found so far. We have 7 full circles. That takes care of this one, and this one. So that's 3 halves, 4 halves, 5 halves, 6 halves for 3 full circles. We've done this one paired with this one paired with this one paired with this one, and this one paired with this one. Now, not that we're forgetting it, but we're just doing this in steps. After I find those 7 full circles, what am I going to do now? I don't have these ones yet, right? So Carter, what is that going to be? Okay. I was thinking of it differently, but I like that. So let's just take this piece right here, right? And that piece I'm going to take and have it, oops, that's not what I wanted to do, and have it join this one to now make a full circle, right? So this piece here is now gone because it's over here, part of that one. And this piece, I'm going to take that one. That was not drawn very nicely at all. Again, the power of technology. I can take that piece. It's no longer going to be there. It's going to be down here, part of that circle, to make another full circle. So that piece is gone and been moved. And the last piece, another 1/4 of a circle, I'm going to take I don't want that piece, though. And move down here, and then I've got a third full circle, right? All right, because that piece was moved down here, this piece was moved down there. So we really have an extra 3 full circles in those corner pieces. Altogether, how many full circles do we have? 10 full circles. So whether you do this in parts or you do it all together, since I have 10 full circles, I just need to find the circumference of one full circle. And the circumference of one full circle, let's see, circumference of one circle is going to be the diameter multiplied by pi, yes? Okay, well, but 2 times pi, here's where I'm going to probably do it different than you. The circumference is 2 times pi, and I have 10 of those full circles, so 10 times 2 multiplied by pi. I'm not going to round until the very end. 10 times 2 times pi is equal to 20 pi. And now simplify that. Let's round to the nearest tenth, 20 pi. Go ahead, Trace. 62.83 would round to the nearest tenth to 62.8. 62.8 inches in wire. Yes, Carter? Did you get the same answer? Then that's what matters. If you have a brain that works a little bit differently, you can do it a different way. This is just the way that whoever got me started, that's how they started it, and so I just went with it, and I like it. And if you did it a different way, that's great. But for the sake of time, we're not going to be able to go over another way. Let's do that not on the recording. Thank you. If the wire picture frame were stretched out to make one complete circle, so I'm taking all of this wire, and I'm going to stretch it out and make one complete circle, what would its radius be? Talk with your groups about that one. We'll come back together. We're going to pause the recording again. We're now answering question 2. I know how much wire I have. What if I take all that wire, stretch it out to make one big circle? What is that radius going to be? Pause the recording here and get going. Ready, set, go. All right. This is the total amount of wire that's used. So in part 2, that total amount of wire is the circumference. So now this becomes a problem a lot like our warm-up. If I know the circumference is 62.8 inches, and I know that I can find the relationship between the circumference and radius by multiplying 2 times the radius times pi, then all I have to do is substitute this value in for the circumference. 62.8 is equal to 2 times the radius times pi. I want to find that radius, so I divide each side by 2 and pi. Round to the nearest tenth here. What do you get? I have a feeling I know what it's going to be. Joshua. It is 10. You can see it up here. If I didn't simplify, I would have had, instead of 62.8, I would have had 10 times 2 times pi is equal to 2 times the radius times pi. So when I divide by 2 and pi, I'm dividing by 2 and pi. Do you see how there's a 2 and a pi in each? That means the radius is equal to 10 inches. Yes, Joshua? Mm-hmm. Yep, exactly. Okay, let's summarize. The circumference of a circle is pi times the diameter, and the diameter is twice the radius. So if we know any one of those measurements for any particular circle, we can find the others. It is important that you understand the relationship between all of these. You need to understand that 2 radius is the diameter. You need to understand that the diameter times pi is the circumference. And you need to understand that the radius doubled, then multiplied by pi is that circumference. So all formulas and relationships that you need to know. The rest of it is just giving us another example. And for the sake of time, I'm not going to go over that specific example. Just need to understand that if I know one of those measurements, I can find all of the others. So in this cool down, Circle A has a diameter of 9 centimeters and circle B has a radius of 5 centimeters. Which circle has the larger circumference? Make sure you're careful here. Circle A has a diameter of 9 centimeters and circle B has a radius of 5 centimeters. It's better to compare apples to apples. So instead of talking about the radius here, let's change it to the diameter. What is the diameter of circle B? Trace. 10 centimeters. We're going to double that radius. So without even doing the calculation, which one is going to have the larger circumference? Circle A or circle B? Yep, circle B. Question 2, about how many centimeters larger is it? In order to answer this question, that means we need to find the circumference of each one. So the circumference of circle A. A circumference is equal to the diameter multiplied by pi. Don't worry about calculating that. Just go with circle A circumference is 9 times pi. Circle B circumference is equal to 10, the diameter, multiplied by pi. And again, don't calculate that. Let's just keep it like this. How many centimeters larger is it? Let's see. B is 10 pi centimeters. If I want to know how much larger it is than circle A, we're going to do subtraction to figure that out. 10 pi minus 9 pi. You might think, I don't know how to do that, but it's really no different than saying 10 whole Thanksgiving pies take away 9 whole Thanksgiving pies is equal to 1 whole Thanksgiving pie, or simply pi. The units are the same. It's pi. 10 pi minus 9 pi is equal to pi. So how many centimeters larger is it? It's pi centimeters larger. That's it for this lesson. Your practice problems are the lesson 4 practice problems, more applying circumference in each of these problems. That we'll see you next time. Thank you for watching. Bye-bye.